rockets are not the only thing that can take off from a spaceport. Jets, suborbital aircraft, and unmanned aerial vehicles are reaching for space. As I was researching horizontal and non-rocket options for spaceport study, I came across this Canadian-American UAV company that is doing some exciting things in near space. Today's guest is a pioneer in UAV technology that soars to near space in the stratospheric flights that sniff out weather conditions and carry CubeSats up to 30 kilometers in a near space testbed. Please welcome Stratodynamics CEO Gary Punsack. So welcome to the show today.
Thank you, Izzy. Happy to be here. My pleasure.
Space is an amazing industry that's full of challenge and excitement, but UAVs are also amazing. They move under streets inspecting our pipes, they fly through the air inspecting our bridges, and now they can sniff the atmosphere from near space. Do you want to tell us a little bit about your company, Stratodynamics, and the new Hydron that you are flying in the atmosphere?
Yes, we thank you, Izzy. Pleasure to be here. We have a UAV called the Hydron, which is a high altitude aircraft that flies in near space or the stratosphere from typically from about 100,000 feet. It goes up with a weather balloon, classic weather balloon, a latex balloon, and it's released at our target altitude, and it flies back, carries a client's payloads that do various things of either some kind of atmospheric monitoring or studies or carrying a camera or viewport, and then it returns and lands at the runway, lands at your feet, as you like to say, it comes back home. Which often, if you're doing anything kind of high altitude research with instrumentation, it's often goes up with a balloon, and sometimes it's lost or not retrieved. So our system collects data on the way up and on the way down, and combine that with all the flight data. Our clients get a wholesome information to do their whatever they're looking at or studying.
So, what kind of research are you doing up in the atmosphere?
Well, we've carried various payloads. We've done some turbulence detection work, and I should mention we're also developing a turbulence detection technology uh, for measuring turbulence ahead of an aircraft, which is a problem for the aviation industry. But the other instruments that have been on there are ozone detection systems. We've had a camera for looking at air glow or looking upwards into the atmosphere. And so we've done a number of trials with that. Other applications are for surveillance, some kind of camera, looking upwards or downwards, and also um, any kind of infrasonic or ultrasonic measurement of turbulence we've used as well. So the number of ranges of uses, looking at aerosols and particles in the atmosphere, extreme weather, monitoring effects of the thunderstorms in the stratosphere, and other things that are climate related as well.
One of the things that is the narrative going around is that space is just a playground for the rich, but there is actually a big climate need that is going on right now. We have a climate crisis that we need to address. So, how does Stratodynamics do that?
Well, climate in the stratosphere, the effects of climate in the stratosphere is not as well understood as it should be. Like as I mentioned, there are aerosols that or pollutants that get transferred in the atmosphere from wildfires or from dust storms that can get transferred all the way around the globe. And how does that impact climate and weather? There are some researchers looking at that, but it's not well understood. As well as the mixing that happens between the tropopause and the stratosphere can also drive climate and have climate effects, and things like gravity waves as well might move air masses around, and they are predicting that with climate change, for example, that turbulence events will increase by three times. So we're likely to see more turbulence, more weather events from climate, and some of that is driven from the stratosphere. Another interesting aspect is, with the space industry, there's going to be lots more rocket launches, and we and I think there's going to be emerging interest in what is the effect on emissions that are from rockets that are in the stratosphere as well. It's still largely unknown, and so studying those effects would be useful, as well as even the Hydron can provide kind of forecasting abilities before a rocket or a high altitude aircraft is flown to kind of detect the conditions for flight to help, either make a safe flight or expand the operating conditions. So it kind of has the application twofold there. One is to kind of be like a weather sniffer before a rocket launch or a high altitude aircraft launch, the takeoff and landing in the aircraft sense. But also, what are the effects of all the rocket fuel emissions that are left as traces in the atmosphere, in the lower atmosphere, and particularly in the upper atmosphere, was another emerging field of study.
Well, and that was one of the questions that we missed earlier was why do you do this? Why Hydron? Why Stratodynamics? What prompted you to go in this direction and do this particular technology?
I've a, I have a deep personal drive to kind of be able to interest in looking at using technology that can kind of not necessarily take advantage, but can kind of use harmonically energy that's already natural. So, like I'm a glider pilot, for example. So glider pilots rely on naturally occurring convection to stay up for longer periods and using no fuel. And so the concept of a glider is a highly efficient aircraft, and we know aircraft have to get more efficient to be able to save fuel. And so part of the work we're looking at is also, looking at efficient aircraft that can stay up and utilize, fly efficiently with less fuel, but also harness things like gravity waves, perhaps, and stratospheric mountain waves to extend, duration of flight. In an autonomous way, and maybe eventually with manned aircraft as well. But so those are kind of the drivers behind, why we've taken the approach we have, using, a highly efficient aircraft to fly at, really record-breaking heights.
Marketing strategies related to our guest visit can be found on spacemarketingpodcast.com in the Show Notes Expanded section, with corresponding page numbers to the strategies in my book, Space Marketing: Competing in the New Space Economy, available on Amazon and Audible. Stay tuned, and we'll be right back. Climate is a big thing right now, the climate crisis. So I heard you talk about a few things. You said air glow. Was that one of the things that you mentioned as far as what you were looking at? I don't know what that term means.
Yeah, I mean, I'm not the expert in this particular one, but this particular researcher was looking at the changes in air glow as as a proxy for measuring the effects of cosmic rays. So this was a different study where they had a camera looking upwards to measure cosmic rays that were entering through the atmosphere, and it could be measured by changes in air glow. Not necessarily, I don't know if that's related to climate, but a lot of things that are related to climate change are obviously measuring ozone, particles in the atmosphere, dust that gets transported in stratospheric corridors around the world and can impact climate. We're particularly interested in looking at things like gravity waves and atmospheric waves that can cause mixing between the lower atmosphere and the upper atmosphere, and may drive climate as well, may move maybe circulating air in different ways. And these particular properties are not well known, but there are people studying these kind of atmospheric properties around the world.
So one of the things that the Hydron can do is carry up a CubeSat for doing this type of testing, correct?
Yeah, one of the aircrafts that we're developing now, a larger one that can carry a 5 kilogram payload and a 5U CubeSat, so is designed around being able to trial any technology that wants to go into orbit before it gets there. So this is a cost-effective way to trial an equipment in near space conditions, which are low temperatures and thin atmosphere, test radio links or test the performance of the equipment optically or what have you before it gets deployed. So it's a cost-effective way of developing a piece of technology that will be later space deployed.
So going to space is hard, but going to near space is also hard. You were I've read some things and we were discussing about how the atmosphere is only about 1 to 2% air, and aircraft need air in order to fly. Do you want to tell us a little bit about that?
Yeah, well, getting to the stratosphere, even though it's close, it's 30 kilometers or less, 20 kilometers or above the tropopause. It's relatively close in distance relative to how far you can drive in a car. It's actually hard to get there. And the atmosphere is so thin at those altitudes as well, as less than 1% of the atmosphere. So the air is very thin. It's like a Mars-like environment. And so flying at those altitudes requires, has a different aerodynamic challenges with that aircraft because the properties of the air are different when it's thin. And there hasn't been any aircraft, very few aircraft have flown at those altitudes. Um, you know, Fuel burning aircraft don't fly that high. But it's possible. It is possible to fly. We've been able to fly in those types of environments and fly from, above a high altitude aircraft and fly with an efficient aircraft as well. It's not well known how to do it. There's no textbooks, aerodynamic textbook to how to fly in those types of environments. So we are working on developing a custom built aircraft for what we call a low Reynolds number environment, very thin like environment that can fly as efficiently as possible and stay up as long as possible in that type of atmosphere. Future applications are for that, aircraft that could fly on Mars, or just to continue to fly efficiently at high altitude for aircraft that can stay up in an area for long durations and fly. We are looking at those other effects like stratospheric mountain waves and gravity waves and other atmospheric properties that perhaps we could harness with our aircraft and extend the duration, soar like a glider would, gaining a lift from other properties and extend its flight duration. So this is all pioneering work that we're trying to do, and hopefully we'll be some success and looking to do more.
Well, you've broken some records. What's the highest you've ever been able to fly?
About 33 kilometers in altitude, so 100,000 feet. We've released from it. It's possibly to go higher than that as well with a weather balloon. Um, and so we've been able to fly about 6,000 feet higher than SR-71 Blackbird, so from 90,000 feet. So when we release from a balloon, the aircraft accelerates quickly, it kind of drops and it has to pull out and then it flies from those altitudes. And so it's flying incredibly fast as well relative to the ground. The ground speed is quite high. The airspeed is still about the same, surprisingly, but the ground speed is really fast. And so maintaining flight at those altitudes has some unique challenges. We've been working with our collaborators, UAVOS, who developed the autopilot system to get the control systems there. As I mentioned, unique challenges when you release from the balloon at kind of a microgravity environment. It accelerates so quickly. It goes transonic within matters of less than 2 minutes. So if you don't get it under control, you can be doing high speeds, and then there's aerodynamic penalties for that. You've got lots of turbulent flow on the aircraft, and it becomes challenging to control, or can be. And so being able to pull out quickly and smoothly is something we've been able to do, and we're quite proud of that. Being able to fly at altitudes much higher than any other aircraft at the moment, or higher than most aircraft, I should say.
Well, and just to give the audience a little bit of an idea of how high that is, when you go into a commercial jet, you're only going about 30,000 feet. So this is 3 times higher than what a commercial jet flies. How fast is it falling when it first falls?
Yeah, so commercial aircraft fly about 30,000 feet, so 3 times higher. It can go up to, we've seen as high as 900 kilometers an hour when it's falling. Those are speeds we don't like to fly at. We'd like to fly it at much. So there's airspeed and then there's ground speed. The airspeed is still relatively light, like 20 meters per second, or less than 20 meters a second at altitude. But on the ground, that could be over 100 kilometers an hour as well. So we try to fly, we try to keep the speeds under control is the goal, really, not to fly super fast. But it's relative. It's just a property of flying in thin atmosphere. You have to fly faster relative to the ground to maintain a certain airspeed to keep the aircraft aloft.
What is the next challenge that you have? I know you've got some exciting things on the horizon right now.
Well, we're developing this custom aircraft to carry a 5 kilogram payload and a CubeSat size aircraft that should be ready next year. And the development of that is unique because there's no aerodynamic textbooks that can really explain how to fly at those altitudes because it just hasn't been done much. So we're using leading experts around the world to help with the design that we can find, and that should be ready. So that's going to be, we're quite excited about that aircraft. The goal is to be able to stay up longer at those altitudes, fly more efficiently. We're also developing a turbulence detection system. So if you've been on any kind of aircraft, commercial aircraft, and the seatbelt sign comes on, and hopefully it'll be mild, but it can be severe and people can get injured. It's actually the leading cause of injury in the commercial aviation space, injury to crew and passengers. And it can also, damage aircraft as well. So it is a significant problem. At the moment, aircraft have very limited means to detect turbulence ahead of the aircraft. And so with the technology we've licensed from NASA and with our other collaborators, we're developing a system for detecting turbulence ahead of aircraft. And so it's in some flight trials now, and we've done some in the past on our own UAVs and others, and we look to do more of that commercialization of this technology in the future.
So, one of the places that you've partnered with for this is, as you said, this is a NASA project to determine turbulence. You want to talk a little bit more about your partnerships and where you actually flew out of when you did your test flight?
Yeah, one of the recent projects we did at Spaceport America in New Mexico, we were collaborating with the University of Kentucky and also NASA colleagues, the inventor of this turbulence detection system and or systems at both those institutions came together. So two sensors that were developed to kind of provide a predictive means of detecting turbulence were trialed together side by side in a high altitude flight as well. So that was a collaborative effort with those two institutions as well as our autopilot developer UAVOs. So we're quite happy to work with collaborators on these things. We learn a lot, they learn a lot. There's a bit of a cross sharing of technology, and it helps it ultimately advance the technology and so it's very beneficial to us and to them and to the industry generally to be able to advance these things. So in that particular case, it was a kind of partnership between the three institutions, including ourselves, but also the University of Kentucky and NASA. And that whole program was funded by the NASA Flight Opportunities Program, that paid for or funded the flights as well at Spaceport America. So multi-agency involvement there.
Well, one of the things when you partner with other companies, you also expand your message, the possibilities for your messages. So what have been some marketing challenges that you've experienced during this journey to near space?
Our Hydron platform can carry multiple kinds of instruments, and everything from, say, atmospheric monitoring to surveillance to CubeSat development. And these technical people mostly, but the customers and clients kind of live in different places. They go to different forums, they go to different conferences, and so finding them is been a challenge for us, and for them to find us and be aware of us has been a challenge. We've been useful or been successful using kind of networking and reaching out to clients kind of on a direct or one-to-one basis. So it's been challenging for us to get in front of whatever media that our clients potentially use. It's pretty diverse, pretty widespread, and so that's been a challenge, just to try to find clients that are aware of us and we can provide a benefit to them as well.
Well, one of the things that you do that's unique is that you have a person that is in charge of your marketing and that spearheads a lot of that effort. What are the type of things that you have done that has been extremely successful in getting the message out?
Yeah, my colleague Nick Crane has in head of marketing, and he's been an expert at developing these kinds of our outreach. And we use a lot of our imagery that we get from our Hydron and put together videos. And the stunning imagery that we capture off the aircraft. One of our images that I think you'll feature here was selected as a NASA image of the day, for example, a stunning picture of the Earth from with the sky and the curvature of the Earth and the thin atmosphere. So utilizing a really strong graphical or visual presence is been successful for us, and putting it together in kind of an interesting, compelling way. I think that's to Nick's credit. Almost taking a filmmaker approach to getting our message out. Compared to some other technical information that can be kind of dry and hard to sustain your interest. These are kind of we utilize stunning imagery that really can capture people's imagination and has been an attractor for us.
Well, in the picture that you're talking about, the one particular NASA image of the day is where you can see the tail of the Hydron and you can see the curvature of the Earth and the blackness of space. It is really amazing and it has a story to tell. A lot of businesses don't realize that you you have a lot of very good imagery that you can do if you do it on purpose and if you create those opportunities for it to happen. So you have a camera specifically on the Hydron, and some of it's for research, but some of it's just for this, correct?
Yeah, it's got kind of two purposes. We can sort of monitor what the aircraft is doing and seeing if some impacts that the aircraft might be having from the environment that it flies through. But secondarily, it also carries, not secondary, but also carries some really stunning imagery. And, it does tell a great story. I mean, it's an opening story to say, we were here. We were at this point where we were, in near space. And, that's tells that the company was able to achieve those heights and success just in one image, so it's pretty fantastic use of the technology and the cameras. And these cameras aren't very expensive as well. I mean, and they provide really great resolution. So it's a very, very compelling. Yeah, you can tell a lot, 1,000 words in one image. And I think some of those images do tell a great story.
And make sure you get video for everything. Like you said, this is one of the areas where it's been a very big success for your marketing campaigns is to actually have great video of all your flights with Spaceport America and those type of things. Spaceports are the gateways to space. Each spaceport offers a different set of services. On the flip side, as a company that uses spaceports, you have a choice to use different facilities all over the world. In fact, you can move pretty easily, and that's part of the benefits that you've built into your company is being able to go anywhere. What type of criteria do you use when determining what facility to use?
Yeah, that's a great point. I mean, we have a very lightweight aircraft. It can be mobile, so we can transport it around quickly to an areas that our clients need. Some have specific interests for a particular geographic area or region, or flying over water or land. So being able to access multiple spaceports is a benefit for us and what we offer. And because UAVs are somewhat of at these applications or at these altitudes, flying through many classes of airspace is still kind of relatively novel. The regulatory airspace is still emergent, if you will. Um, so the BV loss beyond visual line of sights of applications and restrictions, you know, can limit a lot of places that you can fly at. And it also depends on what class of airspace you're flying at. So we're flying out through what we call visual flight rules, which is typically aircraft operators that fly at lower altitudes that require the pilot's visual sight to fly, and then high altitude classes where it's by instruments, and instruments can provide locations of aircraft. And so what we look for is spaceports that have kind of access to restricted airspace that can be controlled in a way that can limit other aircraft from entering the space, and that kind of provides a proxy for separation from manned and unmanned aircraft for the moment. I mean, at some point, we'll be all sharing the same airspace. It's not quite there yet, but it's coming. And so spaceports have that advantage of typically they have access to restricted airspace from the ground to unlimited for vertical or for horizontal launches. So for vertical would be with rockets, etc. But we're using an aircraft, and so we would look for spaceports that have that access, and if they have the complete access from the ground up to the area that we want to fly in or above, that's even a better benefit or more interesting for us. Because it helps manage the approval process, which can be cumbersome.
Let's talk about Spaceport America a little bit and your flight that you had there in New Mexico. You had to use a United States-based company because you were working with a particular contract. And what drew you to Spaceport America specifically? You had a choice of, well, there's 13, 14, the 14th just came online, but wasn't an option at the time.
One of the things I liked about Spaceport America was they had access to airspace from surface to unlimited, which we were, flying right from the ground all the way up to above. Typically, airspace kind of caps out at 60,000 feet, but we were going higher. But anyhow, they had unlimited airspace, or had access to restricted airspace from their own airspace and also the neighboring airspace in collaboration with White Sands Missile Range. And so it provided an ease of getting flight approvals to some degree through one controlling agency. Some of the spaceports might have access to a portion of a flight regime. So they might have up to a certain altitude or from a certain altitude and above. And so in our case, as a UAV operator, we would have to go get flight approvals from two agencies, which and it could take a long time to do that, and we just want to be able to fly our aircraft. So one of the advantages of Spaceport is that they had access to this airspace which we could do our operations in. So that was one key factor, and also they have the facility there. They have a long runway. They provided access to a place where we could set up our aircraft and run a mission, and we're pretty accommodating in the costs and as well as the operation, and allowing us to have a flexible schedule as well. Our campaigns require certain kinds of wind conditions and things like that, so it has to be somewhat flexible, and they were easy to work with.
And I'm going to ask a two-pronged question now. What advice would you have for a spaceport that's interested in attracting users like yourselves or tenants?
Yeah, well, I think for UAV flights, it's the access to airspace, and so being able to do your complete flight mission, preferably with one controlling agency, and so that's a great asset. If you can also, or if that's not possible, to have one sort of go-to way interface, if you will, to manage that with other controlling agencies of the airspace to facilitate getting the approvals. The approvals can take many, many months in national airspace, and so having a way to expedite that is very helpful and attractive. If a spaceport can kind of facilitate that interaction with all the other parties, stakeholders, that's a big value, big benefit. On top of that, we operate kind of a portable system. We kind of show up for a couple of week period, and then we set up our system and go. So having a facility available that can do that, we don't typically need a lot of space, but at least having something that's got all your power and internet and access to run a campaign is helpful as well.
Now, the second part of that question is, what advice do you have for other space companies or other companies similar in reaching for the the atmosphere. What advice do you have for them?
Well, general advice would be to have a business model that looks at really solving a problem or a business, providing a solution for a business need. That's kind of core advice. The a lot of you know people in the it's a very technical industry, so a lot of sort of business ideas are generated from technology first, and then trying to find a place where it fits. And I think you know focusing on the problem and then finding the technology that fits the solution is recommended. Um, and that's one core business piece of advice. And then in terms of the industry itself, it's a lot. Even if you're doing a business to business or a commercial application, there are a lot of the potential clients in our case that are either grant funded or government funded, and so the sales cycle on those tends to be long, and so we help with writing grants and proposals for our clients as well, but it can be a long sales cycle, so you have to be prepared for developing that, for having long sales cycles and having multiple things on the go. And I guess then depending on the actual need that you have, it could vary in terms of the technology. So it's really finding the great fit between the technology and the business need, that will help make it easier, or just take longer, or make it more successful.
That's great advice. Most people, they try to make things fit into a niche where you should look at what the niche needs first. And are there any final thoughts you want to leave our audience with about the Hydron and in Stratodynamics today?
Well, yeah, if you've got a particular application that you want to get to near space, for whatever the reason, for monitoring or surveillance, or for looking at it, we're a company we like working with people. It's usually a custom approach, so we help even write proposals if need be, but we customize our aircraft for your needs, and you run a campaign to match your needs, so please reach out to us. Secondly, if we are developing our turbulence detection system, and we are looking to get on as many flights as possible at the moment, or even ground-based systems as well. So near airports that are need to look at turbulence in and around airports as well. But we're developing the airborne-based system, and just need to get more airtime with it to help develop it. So please reach out to it if you're interested in an airborne system for detecting technology and want to trial our system. Happy to talk to you and collaborate. You can look at our website, Stratodynamics. You can find all of our contact information there. Reach out by email, or please give me a call.
Awesome. Well, is there anything that we missed that you wanted to touch on?
No, thank you very much, Izzy. It's been a pleasure to talk to you, and yeah, please feel free to reach out to us if you think we can work together.
And thank you again for joining us today. Please subscribe before you head on over to the YouTube channel for bonus footage. Links to YouTube and other social media channels can be found on spacemarketingpodcast.com. A special thanks to Gary Punsack from Stratodynamics for joining us today and sharing his company's journey to near space. Be sure to check out Stratodynamics links listed in today's show notes. I hope that you have found this podcast useful for your journey as you reach for the stars.